Hello my dear students, I am Divyam and I am welcoming you all in another video. In this video, we are going to discuss about the electrophilic substitution reaction of benzene. But before going to start my video, I want to show you some of the questions which are very important for your examination point of view also, and this concept is basically asked in the JEE NEET paper also. So these questions are given in your NCERT in text portion, and also some of the questions, two questions are in between the paragraphs which is given in your hydrocarbon chapter. So the very first question is that why does benzene undergo electrophilic substitution reaction easily and nucleophilic substitution reaction with difficulty? The next question is suggest the name of Lewis acid other than anhydrous aluminium chloride which can be used during ethylation of benzene, means during the Friedel-Crafts alkylation of benzene. Next question is benzene gives substitution reaction normally but addition reaction only at harsh conditions. Why? And the last question here is why do we get isopropyl benzene on treating benzene with 1-chloropropane instead of N-propyl alcohol? Means product instead of this, because we have taken 1-chloropropane as a reactant. So these questions seems very easy, but yes, they have specific concept which you need to understand, and after I complete my video you are going to answer these questions by your own. So let's start with the video now. There are 5 electrophilic substitution reaction which you have to study: nitration, halogenation, sulfonation, alkylation and acylation. And the mechanism is also given in your NCERT. So let's start with the reaction first and then we will move on to the mechanism part, because mechanism itself make you understand that why certain products does not form in these type of reactions. So the very first reaction is nitration. So nitration, if we have nitrating reagent and we treat benzene with nitrating reagent consists of concentrated H2SO4 and concentrated HNO3 nitric acid. This gives nitrobenzene and water molecule are in certain amount of heat. We get what? Nitrobenzene. The halogenation of benzene required a benzene molecule plus the chlorine molecule, anhydrous AlCl3. We can take here FeCl3 also, and if we are taking Br here we can take FeBr3 also. There are different Lewis acids, FeCl3 and FeBr3 also. So it will convert benzene in an HCl. We does not get the product this. We didn't get this product, but we get this product. The answer of getting this product is hidden in its mechanism part. So we will discuss this case in the mechanism part, that why benzene on reaction with Cl2 gives this chlorobenzene apart from this. All right. The next reaction is sulfonation reaction. So if we treat benzene with fumic sulfuric acid, means oleum, and if we heat this reaction, sulfonic acid, this is chlorobenzene. All right. The alkylation reaction means if we want to add a methyl group on the benzene, methyl or ethyl, so we have to react the benzene with chlorobenzene or any alkyl halide in the presence of anhydrous AlCl3, Lewis acid, HCl. This, the common name of this product is toluene. Okay, and if we want a benzene with a ethyl group, so we have to take, so this is a alkylation product. The last, Friedel-Crafts acylation. So for this also we need what? Benzene with a CH3COCl on reaction with CH3COCl in the presence of anhydrous AlCl3, we will get acetophenone here. Acetophenone and HCl. Now let's move on the mechanism part. The very first step is generation of the electrophile. Alright, after the generation there is a formation of it, and the last step consists of removal of proton from the carbocation intermediate. Nitration, the first step will be, so for nitration the first step will be generation of electrophile, and you know concentrated H2SO4 and HNO3 is the nitrating reagent here. And you should know one thing, that in this HNO3 behave as base and H2SO4 here act as acid. So if H2SO4 behaving as acid, it means the proton will remove from this H2SO4. So let's have a look on the first step of the nitration. H2SO4, 2 H is here and 4 O is here, so I can write H2SO4 like this also, plus HNO3 H, I can write HNO3 like this. So this lone pair abstract this proton, and the proton of the bond will shift on this HOSO3 group. So what we will get? We will get here, this reaction is in equilibrium, HOH plus NO2 plus HSO4 negative. This oxygen is having positive charge because one of the lone pair is used in the formation of this bond. This is the step 1. In step 2, what will happen? This oxygen is having positive charge, and you know oxygen is more electronegative atom, so this will pulls the electron density toward itself, and this molecule, water molecule, will release from here, and we will get what? We will get H2O plus, and now this electron is shifting towards oxygen, so nitrogen will get positive charge, and we will having NO2 positive, and this is known as nitronium ion. And this is our electrophile. This is the first step of the mechanism, which is consists of generation of electrophile. So for nitration, the electrophile is NO2 positive nitronium ion. You should know that here nitric acid behave as base and sulfuric acid behave as acid. This is a acid-base reaction, and we are getting nitronium ion here. If you will see the first step of halogenation, this consists of breakage of this bond, the bond of Cl and Cl in the presence of anhydrous AlCl3. This electron density shifted toward this aluminium free vacant orbital, because this aluminium chloride was what? Lewis acid. It means the orbital of aluminium is vacant, and it can accommodate the electron of this bond also. So the shifting happens, and this bond get broken from here, and we will having Cl positive plus AlCl4 negative. Now in this halogenation reaction, this Cl positive is our electrophile. We call it as chloronium ion. Alright, now let's move on to the sulfonation reaction. In the proton abstracted here by this SO3, and this electron density shifted toward this group, so we get HSO4 positive. Okay, and this behave as electrophile here, sulfonium ion. Electrophile. Now if we will see the first step of alkylation, it involves the breakage of this methyl chloride bond, this bond by AlCl3, same as the electron density accommodated by the aluminium. This bond is going to break here from here, and we are getting CH3 positive plus AlCl3 4 negative. Same as if you will see the acylation first step. So this is also CH3 C double bond OCl. This bond is going to break. This electron density shifted toward this aluminium. We will get what? CH3 here. So this is the first step of all the electrophilic substitution you can see in nitration, nitronium ion, chloronium ions here, CH3CO. So the second step is, you can see here, the second step is what? Formation of carbocation intermediate. Now we are going to move towards the formation of this carbocation intermediate. We will do it in one step for all the substitution reactions. So let's start. Let's say we are having a benzene, and this benzene is now going to react with the electrophile, which we have seen just now, the different types of electrophile which is generated. And if it comes in the contact with benzene, now you know that the benzene is very rich in electron density. You have already studied that the benzene have electron cloud above and below the ring, and this benzene is electron rich. So this always react with the electrophile which is having less electron density, or you can say which is in the search of electrons. All right, so this benzene always react with the electrophile, it does not react with nucleophile, because nucleophile is having more electron density. So the benzene having more electron density, that's why it does not react with nucleophile, but it easily react with electrophile. So as the electron density, this pi electrons react with the electrophile and form a complex. We call it as sigma complex, because it forms, this pi electron forms a sigma bond with the electrophile. Now you just see what is happening here, that one of the double bond is converting into one of the double bonds electron is going to react with the electrophile. So let's say there is a shifting of this pi electrons to one of the carbons. So one carbon gets negative charge, one carbon gets positive charge, and you know every carbon is having hydrogen in it. All right, now on the negative part, this electrophile is going to attack, and we are having one positive charge here with the hydrogen. So one hydrogen and one electrophile is now attached here. All right, now this carbon is sp3 hybridized, and this complex is known as sigma complex, or you can say uranium ion. All right, now the question arises that the reaction involves, for example, the reaction, if reaction is having Cl positive and AlCl4 negative, it means the reaction is having Cl positive also and Cl negative also. So why this particular complex forms, why there is not formation of this Cl and Cl, this product does not forms, because this product leads to the loss of aromaticity. That's why this product does not forms. We get this complex and then this loss of proton, and then this complex regains its aromaticity, and we get the, and in the next step there is a removal of proton, and we get, there is a removal of proton from here, and we get not this proton, this proton removed from here, and we get a double bond here with the electrophile attached here. So this is the last step of the reaction. It does not involve this product as a last step because there is a loss of aromaticity, but here you can see there is a regain of aromaticity. So always this product forms, this does not forms. So I hope that you have understood all the 3 steps involved here, and also you are now able to answer that why we does not get this addition product and we get the substitution product. And also one more thing, that you know that why we are using Lewis acid, because Lewis acid help in the formation of electrophile by accommodating the electron density. You are clear with all these questions. Here this question is in this question there is a formation of when there is a formation of electrophile. I'm going to write the mechanism here in short. Let's say we are having this Cl and AlCl3 is now first it will react with this and it form a electrophile here. So I will get what? Electrophile here plus AlCl4 negative. And you know this is the, I will write it like this, CH3 CH2 CH2 positive. In one of my video I told you that this is the primary carbon because it is attached to one carbon. This is also a primary carbon and this is a secondary carbon. Then you should know one thing, that primary carbocation is least stable as compared to secondary and then tertiary. So if this carbocation is primary, then this will rearrange itself and we will get what? We will get secondary carbocation. So one of the protons shift from here and we get this CH3 CH positive and CH3. Now this is the electrophile and this electrophile is now going to attack to the benzene ring. Thank you so much for watching.